Hello friends, welcome once again. So now today we are going to discuss things regarding chapter number 6, that is multimedia. As this chapter starts from streaming audio video, before that I actually want to clear some of the concepts regarding what is the difference in between streaming of stored audio video, streaming live audio video and interactive audio video. So as mentioned in the slide, internet audio video has these three basic types. In that, first is streaming stored audio video, then second is streaming live audio video, and third is interactive audio video. So we'll discuss these things one by one in detail. So streaming stored audio video refers to on demand request for compressed audio video files. So here what happens, most of the times when we are dealing with the audio and video files, those file size can be more. So at the time of uploading the files, there are some of the limitations, so that you have to compress those files. So those compressed audio video files will be considered under this category. After that, we'll have the second thing, that is what streaming live audio video refers to the broadcasting of radio and TV programs through the internet. So some of the times what happens, we are going to get the live audio video which can be broadcasted through TV programs or radio. So that will be the second thing. And the third is interactive audio video refers to the use of the internet for interactive audio video applications. So here we are going to use only internet as the media to give or see or hear the audio video files. So for this we need to do the digitizing of audio and video. So before you are going to actually upload this audio video files, you have to make the digitization of this audio and video. So in that, the compression is the first step. So compression is needed to send video over the internet. So audio and video, we are going to do the compression of this, and after that we are going to add this to the application. So this is the introductory part. So after that we'll start with the contents, those that we are going to cover under this chapter as per our syllabus. The first point is streaming stored audio video. So now that we have discussed digitizing and compressing audio video, we turn our attention to specific application. The first is streaming shared audio and video. So what we are going to discuss under this section, first approach is using a web server, second approach using a web server with a meta file, the third approach using a media server, fourth approach using a media server and RTSP. So here we are having the first approach. So in this figure you will find out what using a web server. So client machine is here, then at the client machine side we have the browser, then we have the media player, and at the server side we are having the web server configured. So the client machine, by using the browser, gives the request about the audio video file to the web server, then web server will give the response to the browser, and then the specific browser will retrieve the audio video files to the client. So some of the times this audio video files can be played by using the various media players supported to that audio video files. Then the second approach is using a web server with a meta file. So in that, client machine is having the browser and the media player, and the server machine is having the web server. So what happens here, when the client machine So the second approach is using a web server with a meta file. So here you can see that browser can make a request, that is get a meta file, then server will respond to the meta file request, then browser will send a meta file to the media player, then player will request the web server regarding a particular audio video file, and the web server will give the particular audio video file to the media player. So this is the second approach. So in the third approach, at the client side we will find browser and the media player, and at the server side we will also find the web server and the media server. So what happens here, the browser makes a request to the server, then server will give a response to the browser requests for the meta file, then the media player after that gives a request about a particular audio video file to the media server, and the media server will give a response to the media players. This is the third approach. And in the fourth chapter we are going to use the RTSP, that is real time streaming protocol. So in that what happens, the client machine and the server machine, the client machine is having the browser and the server machine is having the web server. So browser will make a request by using a get meta file to the server gives the response, and the browser gives a meta file request to the media player, then media player will send a request to the media server, then media server will give the response to the media player. After that the media player plays the file and the media server gives the response to the media player. So in that way the live streaming is happen about the audio video files by using real-time streaming protocol. Then the next point under this chapter is streaming live audio video. So here you can see that streaming live audio video is similar to the broadcasting of audio and video by radio and TV stations. So instead of broadcasting to the air, the stations broadcast through the internet. So what happens in case of TV and radio program? The broadcasting is done through the air, but here we are going to do the broadcasting through the internet. So there are several similarities between streaming stored audio video and streaming live audio video. They are both sensitive to delay, neither can accept retransmission. However, there is a difference. In the first application, the communication is unicast and on demand. In the second, the communication is multicast and live. So when you are dealing with streaming audio video, then it is unicast and on demand, and if it is streaming live audio video, then it is multicast and live. Then the next point is real-time interactive audio video. So in this, people communicate with one another in real time. The internet phone or voice over IP is an example of this type of application. Video conferencing is another example that allow people to communicate visually or orally. So nowadays what is happening, we are doing the video calls, we are making the video conferencing. So that is the best example of what? Real-time interactive audio video, because here we are using the internet. So as you know that if you want to enable the video call, the data must be there on your mobile phone, otherwise your video call will not occur. So that is the best example of what? Real-time interactive audio video. Your call, either audio or video, that can happen by using the internet. So the next figure shows us the time relationship about how this communication is occurring, first packet, second packet, third packet, and then the flow about the interactive audio and video. So here we have to consider the delay of 30 seconds to get refreshed the frames, those what we are getting as the live frames. So jitter is introduced in real-time data by the delay between the packets. So as we had discussed the things regarding the jitter is nothing but most of the times it will be used in the live streaming applications. So it is the delay in the receiving signals, as we are expected something and there is a delay. That delay is called as the jitter. The delay in the arrival signals is nothing but we call it as jitter. Then some of the time we are using the timestamp. In the timestamp we are assigning the packets a particular timing. So first packet will be sent by which time, second packet will be sent by which time, third packet will be sent by in which time interval. So as per that, active time and the send time has been considered in between the client and the server based on the timestamp. To prevent jitter, we can stamp the packets and separate the arrival time from the playback time. So jitter can be reduced by adding the timestamp. So playback buffer. So in the playback buffer, what happens? So some of the files have been stored here, and as you know that when we don't have the speed, then our audio or video it's get moving in a circular shape. So that is what, that is nothing but the buffering happens over there. So buffering does what? It can save that much part about the audio video, and when you played it, so it plays that much part. So it is doing the two step as what key till now part will be saved, and after that part it is going to get from the resource. So it is called as a buffering. Then a playback buffer is required for real-time traffic. So most of the times we are using this playback buffer for real-time traffic. Then a sequence number on each packet is required for real-time traffic. So there is a sequence number for each packet in a real-time traffic. Real-time traffic needs the support of multicasting is used over here. Transition means changing the encoding of a payload to a lower quality to match the bandwidth of the receiving network. So this is the same case with the flow control. Means what? The sender is sending something at some speed and receiving is not receiving the things as per the sender is sending. So the matching of the sending and receiving based on the bandwidth, that is nothing but we call it as transition. So in some cases we have to fluctuate in between this sending and the receiving speed, that is called as transition. Then mixing means combining several streams of traffic into one stream. So some of the time what happens, we have to mix some of the combining streams of stream into a one stream. So TCP with all its sophistication is not suitable for interactive multimedia traffic because we cannot allow retransmission of packets. So UDP is more suitable than TCP for interactive traffic. However, we need the services of RTP, another transport layer protocol, to make up for the deficiencies of UDP. Then the next point is RTP. RTP stands for Real-Time Transport Protocol. It is the protocol designed to handle real-time traffic on the internet. RTP does not have a delivery mechanism. It must be used with UDP. RTP stands between UDP and the application program. The main contribution of RTP are timestamping, sequencing and mixing facilities. So timestamping, sequencing and mixing facilities is the main features of this RTP. So we are going to discuss RTP packet format and UDP port used for RTP. So this is the figure for RTP. Here you can find in the application layer PCM, S261, MPEG audio, MPEG 1 video, MPEG video, MPG2 video, motion JPEG. These are the various file formats, supported file formats about audio and video. Then in the transport layer we'll have RTP and UDP, that is what real time transport protocol and user data telegram protocol. In the network layer we'll have the IP, and data link and physical layer is responsible for underlying LAN or WAN technologies. So this is the simple RTP architecture. Then RTP packet header format consists of what? Version, PX, control counter, M, payload type, sequence number, timestamp, synchronization source identifier, contributor identifier, and contributor identifier. So some of the payload types mentioned over here. So type 0, PCM audio, 1 1016, 2 G721 audio, 3 GSM audio, 5 to 6 DV14 audio. Then if type is 7, LPC audio, 8 PCMA audio, 9 G72 audio, 10 11 L16 audio, 14 is the most widely used, that is MPAG audio. Then 15 is G72 IT audio. Then 26 is motion JPEG, this is also commonly used. Then 33 MPEG2 video and 32 MPEG1 video, this is also most commonly used. So RTP uses a temporary even number UDP port. Then the next point is RTCP. So what is RTCP? A real-time transport control protocol. It is protocol designed for the purpose about what? How to send and receive the reports messages by using the UDP port. So as we know that RTP allows only one type of message, one that carries data from the source to the destination. In many cases there is a need for another message in a session. This message control the flow and quality of data and allow the recipient to send feedback to the source. So you'll see RTCP message types. In this RTCP message types there are basically 5 types of message. One is sender's report, second is receiver report, third is source description message, fourth is byte message, and fifth is application specific message. So the codes used for this starts from 200 to 204. So RTCP uses an odd number UDP port number that follows the port number selected for RTP. So the last point in this chapter is voice over IP. Let us concentrate on one real-time interactive audio video application, that is voice over IP or internet telephony. The idea is to use the internet as a telephone network with some additional capabilities. Two protocols have been designed to handle this type of communication, in that one is SIP and the second is H.323. So SIP message is having this following options like what? Invite, acknowledgement, buy, options, cancel, and register. SIP formats. So in that SIP formats you can just say IPv4 address, email address, then phone number as it is mentioned over there. SIP simple session. So in that suppose caller and callee is there, then caller does what? It invites the callee, then callee gives the response to the caller, then the acknowledgement is there from caller to callee, then callee exchanging the audio, and after doing the proper conversation the caller sends bye to the callee. In this way the conversation will occur. Tracking the callee in the critical task. So in that caller and callee, so caller will do what? Invite request will go to the proxy server, then proxy server look up for the callee and it reply to the proxy server, then proxy server invite to a specific callee, and then callee will give the response to the proxy server, then proxy server will give the response to the caller, and caller will give the acknowledgement to the proxy server, and proxy server will then forward the acknowledgement to the callee. In this way the communication occurs. Then we'll have the H.323 architecture. So most of the times this can be asked for your examination. So here you can find that internet, then gatekeeper is there, gateway is there, then telephone network is there, where the telephones are there and by which it can do the communication. So H.323 protocols. So in that, for audio controlling and signaling, there are various codes and the various protocols used. So basically UDP is used for audio, and controlling and signaling TCP is used by making the extensive use of internet protocol. So here is the example of H.323. so here you can find out what the terminal, find IP address of gatekeeper, then H.225 message for bandwidth allocation is from the terminal to the gatekeeper. Then gatekeeper does what? It message for a setup. Then setup can be occurred through the telephone H.245 message compression method negotiation. Then RTP for audio exchange and RTCP for management occurs, and finally Q931 message for termination. So in this way this H.323 architecture works for this RTP, real-time audio and video. So thanks for watching. Here our sixth chapter is completed. So thanks for watching, and we'll meet again about the second chapter. Thank you.